Welcome to the presentation of our work entitled Recommending Green Routes for Pedestrians to Reduce the Exposure to Air Pollutants in Barcelona. This is joint work between the Artificial Intelligence Research Institute and the UPF University in Barcelona. The main issue we tackle in this work is how to recommend green routes to pedestrians that minimize the exposure to air pollutants in a city. Now, pedestrians are the most vulnerable individuals when it comes to air pollution, which can lead to serious health problems. Along these lines, answering this research question could be of great interest for citizens that wonder if there are greener alternatives for their commute, even if it implies walking a little longer. Similarly, public administrations concerned with their citizens' health could be interested in a tool capable of providing greener alternatives to the routes computed by Google Maps, which disregards the exposure to air pollutants. In this work, we provide a solution to these research questions with our green route prototype, showcasing it for the city of Barcelona. And specifically, we can compute routes that minimize the exposure to air pollutants rather than minimizing the total distance as usually done in normal routing problems. The exposure to pollutants is computed by considering historical air quality data provided by the Barcelona City Council. This data source is characterized by very high spatial resolution, since it provides an air quality measurement for each road in the map. On the other hand, it is characterized by low temporal resolution since it's published once per year. Our prototype can also incorporate the data provided by 7 real-time air quality sensors in Barcelona. Now, since there are few data points, this data source has very low spatial resolution compared to the historical one. And finally, to account for this heterogeneity, our prototype incorporates the technique we recently proposed based on a graph neural network trained on the high-resolution historical data. This aspect is fundamental as real-time data can differ significantly from historical data in a certain location. Therefore, accounting for real-time data allows us to recommend green routes with more accurate, hence lower, exposure to the user. This is the architecture of our prototype, showing how the different components interact. Each component is implemented in Python using state-of-the-art libraries for features such as fetching data from OpenStreetMap, routing, and showing the results to the user. In this demonstration, we show how to calculate the green route from Plaza de Catalunya to the Sagrada Familia. The prototype shows basic statistics such as the length of the green route compared to the shortest one and the reduction in terms of air pollutant exposure, NO2 in this example. The prototype then shows the actual green and shortest routes on the map by means of the OpenStreetMap API. And similarly, we can compute green routes that also take into account real-time air quality sensor data. In this case, our algorithm based on a graph neural network first interpolates the low-resolution data from the sensors and then computes the resulting green route. As mentioned before, results can vary significantly when considering real-time data, especially when the route is in the close proximity of a sensor whose measurements are very different from historical data, like in this example. Overall, our tests conducted on popular starting and destination points in Barcelona show a reduction of NO2 exposure of -7.23%. These results corroborate the indication that green routes are very beneficial both for individual and public administrations. Now, similar results have been obtained in other major cities, demonstrating that green routes can be a simple yet very effective solution to improve citizens' health.